Woohoo! We are live. This is Math 60 Intermediate Algebra. This is section 1.6. We are solving formulas and doing geometry. Woohoo! And where I'd like to start is the formulas you should have memorized. Now, I realize that it is likely that at no point did anyone ever say to you, hey, you should know these. Because most of the time in math classes, we math teachers have a bad habit of saying just know everything and that'll be fine. So I've kind of whittled the formulas down to, I think, the four shapes that are most likely to come up. Granted, there are going to be other things you may need to know about geometry. Hopefully you've taken a geometry class at some time in your life. If you do go on to calculus, you will need to take a class called trigonometry or pre-calculus, possibly. And trigonometry and or pre-calculus will involve a lot more geometry than this. It involves, trigonometry, which is like geometry, but taken to the next level. So this is just going to give you what you need for this class. There's a possibility that you should, be studying up with the other geometries or even take geometry. Okay, so let's review. These are some of the shapes. The first one is a rectangle. And generally speaking, a rectangle usually has different length and width, although if the length and width are exactly the same, you get a square. A lot of times people consider the long side the L and the short side the W, but honestly, you can switch them up. So I'm just going to mark one as W and one as L, but it's really random. Now, in some problems, they'll say specifically the long side is the width or the long side is the length. So watch for that. The area of a rectangle, do you guys remember? Capital A equals W times L, or if you prefer, L times W. Remember, we've got the commutative or commutative property of multiplication. So you can switch the multiplication around. Notice that we use lowercase for the length of the sides, but we use an uppercase letter for the area because it's considered a bigger quantity, right? The area covers length and width smashed together, so it's capitalized. The perimeter, or P, is what happens when you start in one spot and then just start walking, and you walk all the way around on the outside. An area, and I'm just assuming we're all in agreement, but perhaps I should double check, the area actually measures how much space is inside. So the perimeter is the outside, the area is the inside. The area usually has a square in its units. So square feet, square inches, square meters, square miles. Whereas the perimeter will just have feet, inches, meters, miles. It won't be square. So this one is, if you walk around, you get a length and a width and a length and a width. So when I was much younger, this is how I remembered what perimeter was. I would have to just write it out. But a lot of people will go ahead and write 2L plus 2W by combining like terms. Or if you want to be really, really, really fancy, 2 times the quantity L plus W. Look at that. You use the distributive property, but you, instead of distributing, you kind of pull the 2 back. It's called factoring. Each of these is a fair formula. You can learn it in any form or all forms if you feel comfortable with that. So hopefully that is something you have in your past. Now, circles are when things get a little, wobbly. A circle generally has a center. Well, circles do have a center, but you'll either know the R is the radius. That's the distance from the center out to the outside. It's exactly the same no matter where you measure it. Or D is the diameter, and that's equal to 2R. The diameter is 2 times r because it's the whole way across. You may know the English of I was diametrically opposed. That means to be all the way. So you and the other person were across a table or across something from each other. So the diameter, I'm going to draw another one, not nearly as good. The diameter goes all the way across, like a Pokemon ball. The radius just goes halfway across. The area of a circle you may have memorized, pi r squared. And again, that would also be capital A. Pi is on most calculators, you can usually find it. Sometimes it takes a little work. I may have picked my one calculator that doesn't have an obvious pi. Oh no. Ugh. Well, it's possible you guys on the video are screaming, it's right there. Don't go in the basement. Pi is waiting. Okay, so I don't see it off the top of my head. But basically, you would either use pi on your calculator or possibly even leave it as the Greek letter pi. And then you're going to square the radius, which is kind of interesting. So this will also have square units, square inches, square feet. The circumference is same thing as a perimeter, but we're going to go all the way around the outside. And the circumference is pi times the diameter, or 2 times pi times the radius, which kind of makes sense. The diameter is 2 times the radius. So 2 times pi r, or just pi d for the circumference that goes all the way around. So the very cool thing that is being obscured by all these formulas, and you'll have this nice cheat sheet full of formulas, not that you could cheat from, but that you would have, and carry it in your wallet with you at all times in case there's a geometry emergency. But one of the really beautiful things that is being obscured by all the detail here is this formula right here. And this is one of the formulas people point to because the ancient Greeks, the ancestors of the current Greeks, there are still people living in Greece, but the people who were there, thousands of years ago, had actually figured this out. And they knew that if you took any circle, little circle, giant circle, little circle, giant circle, doesn't matter how big the circle is, if you take the distance around, which you can measure by laying out a string, right? And then taking the string and holding it straight. And you divide by the diameter, that's the distance across at the widest point, that is a constant number. That is the number pi, about 3.14, and the ancient Greeks knew it. Now, they didn't have all the digits we have now, but it's actually, when I think about it, kind of blows my mind that they were so good and so focused on this that they actually figured out that there was this number that all circles share. So this is I could keep going for hours. I'll try not to, but mathematicians start to talk about the circumference and the diameter. There really is this beautiful, amazing, deep understanding of the world that ancient Greeks had. And I mean, they didn't even have cell phones. So, there you go. Next up, triangles. Now, there are a lot of geometric formulas for triangles. You may remember things like saying a 45-45-90 triangle, a 30-60-90 triangle. You might remember isosceles triangles, equilateral triangles. It's a lot of stuff about triangles. Ancient Greeks loved triangles. It was a big old triangle party. So given all the different kinds of triangles, what do we do with the area? Well, basically, however you're looking at the triangle, the one side that's sitting on the ground is the base. And we're going to look at the length of that. Now, we could turn the paper however you want, and then we could have a new base. But it's however the triangle's oriented. There's the base. And then from the base, you take the top point or vertex, that point there, and then you look down and you draw a line segment that is perpendicular to the base, and that becomes h the height. And the area, which is A, is 1/2 the base times the height. And I'm hoping that you will look at the rectangle and you will look at the triangle and you go, wait, basically here, basically, see what I did there? Basically, L times W is base times height. We're just calling them different things. This is 1/2 the base times the height. So triangles are half a rectangle. That's all. They're just half a rectangle. Now, for the perimeter of a triangle, I always found this very disappointing and somewhat annoying because I was expecting some big, beautiful formula. And the problem is there are just too many possibilities. So there's the formula for the perimeter. That means you start anywhere in the triangle and you go all the way around the triangle. Are you ready? This is deep, guys, very deep. It's the length of side 1 plus the length of side 2 plus the length of, you got it, side 3. Oh my gosh. I know, so disappointing, but it is correct. You just add the sides to get the sum of the sides. Now, the last geometric figure I want to look at right now, and there are a lot of other figures out there, some really cool stuff. But this one I love because back when I was teaching, my very first year of teaching, I taught 9th grade geometry at a private school. And I had a student who said a trapezoid is a triangle that looks like a square. And I have loved that ever since. So trapezoids, they are triangles that look like squares. Now, I'm going to try to write really big because I realize this is so tiny, little tiny writing. And I want you to see what's going on. So we're going to do monster mega trapezoid. And there are a lot of things about a trapezoid. One thing is these two sides, although I've drawn a terrible drawing, these two sides are parallel. And so there is a height here, and it is the same. So you can measure the height here or here. So basically you've got a height. Notice if I draw the line in both places, you see, whoa, look, there's a rectangle and two triangles, and that's going to be the key. The area is going to be the height. And then this gets really interesting, and different people have different ways of writing this. I'm going to go ahead and use A sub 1 and A sub 2. So the length here, and a lot of people use B as well, or A and B. I mean, it's really up to you. I want to introduce subscripts here, so I'm going to use A sub 1 and A sub 2. So you take A sub 1 and add to A sub 2 and divide by 2. Now, I know you look at that and you're like, whoa, this is all of a sudden it's so much. But what is it really? I took this length and this length. If I add two things together and divide by 2, I'm finding the average. So I'm saying this is short, this is long. Somewhere in the middle, there's the average length. I'm just going to multiply the height times that average length. And so that's the formula for area. I just think it's cool because of the logic involved. It's basically a triangle that looks like a square. So you make it kind of into a square. Some people, you can, if you would like, you can go online. There is a way to draw, to find that perfect middle part and then chop off pieces, chop off this little piece and put it up there, chop off this little piece and put it up there and make it look like a true rectangle. So it is possible to do that. Okay, there are our formulas. Having set up all these formulas, you're going to find that the actual homework is a little disappointing, but we will do what we can. So I'm going to keep these close by because we're going to need those formulas. I will point out that on Canvas and in the Google Drive, I will post a copy of all my notes so that you can print them out or save them on a tablet. So if you want just this page of formulas, you'll have it ready. So, 66 feet of crown molding. Already, we are talking ye olde fashioned things. Now, what is crown molding? Well, if you live in San Francisco or in a lot of parts of the East Bay, Oakland especially, and you've got beautiful Victorians, if you look up at the top of the ceiling, you'll see where the ceiling hits the wall. There's like a piece of pretty wood there. That is the crown molding. So crown molding is that beautiful piece of wood, and its job is to hide the fact that walls and ceilings don't always come together in a beautiful way. Houses are not perfect, land is not perfectly flat, and so sometimes walls and ceilings are kind of not exactly perfectly straight. And so the crown molding is just like it's kind of like architectural jewelry or architectural, um, a fancy outfit, little necklace you put around. Now, how do you know it's at the top and not at the bottom? It's the crown molding. So crowns go on your head, so it's the top one. So 66 feet of crown molding was installed around a rectangular dining room. Right off the bat, I draw a rectangle. If the length of the room is 18.75 feet, what is its width? Okay, so I'm going to pick the length and I'm going to say that's right here. 18.75 feet. So right off the bat, when I'm reading the question, I try to draw a picture and I start putting numbers in. So I got a number there. Okay, so there's one of my numbers. 18.75 feet. So I got that. That's my length. And then I've got another number right here. You know what? The green is too dark. Let me do blue. 66. Now this one is sneaky. It's easy to miss because it's written out. You can't just look for numbers for numerals. You actually have to look for numbers that are written as words. So I've got 66 and I'm not sure what it is. And then hopefully you all know that you can write feet as FT. So I've got 66 feet and it says of crown molding was installed around. So if this is my rectangular room, then the crown molding was installed all the way around. So 66 feet must be the perimeter. Didn't leave myself enough room. Sorry about that. 66 feet is the perimeter. What do you guys think? And so what we want to find right here, you always go to the where the question is. That will tell you what you're looking for. I want to know what's the width. Okay. So I've taken notes from the word problem. This is how I write it down. And let's see. Let me get started. So I know what the length is. This is going to be the width. I'm going to let L be the length. 66 feet is the perimeter. That means I need a formula for the perimeter. The perimeter of a rectangle is one of these formulas. I think I'm going to use the middle one because I like that one. So the perimeter is 2L plus 2W. I know the perimeter in this room is 66 all the way around. I know my L is 18.75 feet, and I do not know my W. So there's my L. Here's my 66 feet, which was the perimeter. And the width is the thing I don't know. Okay. So, shall we solve the equation? Let's do it. A couple things. Word problems are, generally speaking, everyone's least favorite part of math. It just is. People don't like doing word problems because they're hard. They change. There's no consistent method of attack because so much can change. Second thing I want to point out, I don't put units into my equation. Now, I know the chemists do, and we will occasionally put units into an equation, but that's a very special situation. So we're going to leave off all the feet. What I do is I make sure my units agree. So in other words, this doesn't say 18.75 yards and 66 feet. These two agree. So as long as they agree, we're good. There's a thumbs up. Okay, so let's see. I'm going to give myself some space here. 66 equals 2 times 18.75 plus 2w. 66, I'm going to simplify before I start moving things around. 2 times 18.75. This is terrible. I don't have you guys in class to tell me what these numbers are. 37.5 plus 2w. Okay, now what do? I need to isolate the variable, which is the w. So I need to move the 37.5. So I'm going to subtract 37.5 from both sides. And 66 minus 37.5 equals 28.5 equals 2w. So then what do? I got to solve for w. What do I do to both sides? You're right. I'm going to divide by 2. 28.5 divided by 2 equals 2w divided by 2. So I get w equals 14.25. So my width is 14.25. Now, what's really important is when you're answering a word problem, you got to make sure you put in the units. Feet. Why feet? Everything else is in feet, so it's going to be in feet because all these calculations were done in feet. Could you check your answer? Absolutely. So we could come back over here. We could say, clear. 2 times 18.75. Okay, 37.5 plus 2 times 14.25. I get 66. Woohoo! Happy days. Okay, there's that one. Now we're at 22 minutes. I'm going to peek ahead. You know what? I'm going to break here. Let's go ahead. We'll do this second problem and then whatever the mysterious stuff is on the next page in the next video. Woohoo! Math on, guys. We're almost done with chapter 1. Woohoo! Yay!